Hello GATE aspirants, welcome to part 4 of GATE quantum mechanics series. Question number 17. Which one of the following commutation relations is not correct? Here symbols have their usual meaning. Now we'll see first one. We know L square Li is equal to 0 always. Then Li Lj, this is equal to I H cross Levi-Civita tensor Ijk and Lk. So option A and B are correct. Now for option C, we have Lz, L plus. So this will be equal to Lz and this is Lx plus I Ly. So this is equal to Lz, Lx plus I Lz, Ly. Lz, Lx, Zx. So they are in clockwise direction. So this will be equal to I H cross Zx, Y plus I into Zy. So this will be minus 1. So minus I H cross into Zyx. We can take I H cross common. So this will be, here it will be Ly. Now this is I into I. So I have to keep I here. We can take H cross common. Then I into I is I square, that is minus 1 plus 1. So plus Lx. And this is equal to L plus only. This will be H cut L plus. Next we have, so option C is correct. And for last option, Lz L minus is equal to Lz Lx minus Ly, which is equal to Lz Lx minus of I into Lz Ly. This will be equal to, for first one it will be I H cross Ly. Then we have minus of I into, this is minus of I H cut Lx. Now I square is minus 1, minus minus minus. So this will be minus sign. We can take H cut common. So this will be I Ly minus of Lx. So this is equal to minus of H cut L minus. So we are getting third relation, that is Lz, if we are considering Lz. And here we have L plus minus, then this is equal to plus minus H cut L plus minus. So here option D is wrong. So correct option is D. Next, a proton is confined to a cubic box whose sides have lengths 10 to the power minus 12 meter. What is the minimum kinetic energy of the proton? The mass of proton is given, Planck's constant is given. Now particle is in 3-dimensional box, so En is equal to nx square plus ny square plus nz square into, we have pi square h cut square upon twice m width square. Let us assume width is a. Now for the ground state, nx, ny, nz will be 1, 1, 1. So that means this is 3 pi square, and we have here h cut square upon twice m a square. H cut square is h square upon 4 pi square. So that is 3h square. 4 into 2 is 8 m a square. So this is equal to 3 into h is 6.63 into 10 to the power minus 34 square upon 8 into mass of proton is 1.67 into 10 to the power minus 27 into 10 to the power minus 12 square, and this comes out to be 9.87 into 10 to the power minus 17, which is nearly equal to 9.9 into 10 to the power minus 17 joule. So option C is correct. Next question. A spin half particle in a linear superposition of 0.8 upstate plus 0.6 downstate of its spin up and down states. If up and down are the eigenstates of sigma z, then what is the expectation value up to 1 decimal place of the operator 10 sigma z plus 5 sigma x? So psi is equal to, we have 0.8 into upstate plus 0.6 into downstate. So this is equal to 0.8, then we have 1 0 here plus 0.6, 0 1. So that is 0.8, 0.6. That means this is Ket psi and Bra psi will be 0.8, 0.6. Now Ket psi and Bra psi Ket psi, this will be 0.8 square plus 0.6 square, that is 0.64 plus 0.36, which is equal to 1. So this is normalized state, and we want to find out expectation value of this operator. Let us first calculate that operator. A is 10 sigma z plus 5 sigma x, that is 10 into sigma z is 1 0 0 minus 1 plus 5 into sigma x is 0 1 1 0. So that is equal to 10, here 5, then 5 and minus 10. We want to find out its expectation value. So by definition this will be psi a psi upon psi z. Denominator is 1, we have already calculated it. So this will be equal to 0.8, 0.6, then a is 10, 5, 5 minus 10, and here 0.8, 0.6. We have to just multiply these matrices. Now 10 into 0.8 is 8, into 5 into 0.8 is 3, so that will be 11. This 5 into 0.8 is 4, and this is 6, so this will be 4 minus 6 is minus 2. This will be equal to 11 into 8 is 8.8 minus 1.2, which is equal to 7.6. So up to one decimal place, and answer is 7.6. Next question. Consider the wave function. Wave function is given psi is equal to a e raised to I k r naught by r, where a is the normalization constant for r is equal to 2 r naught. The magnitude of probability current density up to 2 decimal places is. Now probability current density J is equal to I h cut upon twice m, and in bracket we have psi del of psi star minus psi star and into del of psi. So we have to calculate this now. Let us first calculate dou psi by dou r. That will be a e raised to I k r minus of r naught upon r square plus a into r naught by r e raised to I k r into I k. Now we can take this a e raised to I k r and r naught by r common. So this is a e raised to I k r naught by r. In bracket we have I k minus, so this r naught is also common. So that is equal to into 1 by r. So this is equal to psi into ik minus 1 by r. Next we have psi star is equal to, just change the sign of I. So this will be a e raised to minus ikr into r naught by r. So now dou psi by dou r is equal to a e raised to minus ikr. Then we have minus of r naught upon r square. Then here we will have a r naught by r e raised to minus ikr into minus ik. This we can take common. So a e raised to minus ikr r naught by r. In bracket we have minus ik minus 1 by r. And this first portion is psi star. This is psi star. So psi star in bracket minus ik minus 1 by r. So we have calculated all these values. Now we will substitute here. So J is equal to I h cut upon twice m. Then we have psi, and this is del psi star, and that is equal to psi star in bracket minus ik minus 1 by r minus psi star, and del psi is psi in bracket ik minus 1 by r, and whole thing is in brackets. So J is equal to I h cut upon twice m. We can take this psi star common, and psi star will be, this is psi and this is psi star, so that is equal to a square r naught square upon r square. And in bracket we have minus ik minus 1 by r minus ik plus 1 by r. So this will cancel out. J is equal to I h cut by twice m into a square r naught square Now r is equal to 2r0. So this will be 4r0 square into this minus 2 ik. Now I into I is I square, and this minus sign will cancel out and this 2 will cancel out. And finally you will get j is equal to 1 by r. Then this r0 will also cancel. Then a square h cut k upon m. So in the units of a square h cut k by m, this is 1 by 4. So answer is 1 by 4. And we have to write it up to 2 decimal places. So 0.25 is the correct answer here. Next question. To the given unperturbed Hamiltonian, we add a small perturbation given by this. So this is the perturbation matrix. This will be our H0 and this is some H dash. The ground state eigenvector of the unperturbed Hamiltonian is. That means we have to solve this matrix and get its eigenvectors. And this is for unperturbed Hamiltonian. So this is H0. So you will simply write mod of H0 minus lambda I. This should be equal to 0. That will be equal to 5 minus lambda 2 0. Then 2 5 minus lambda 0 and 0 0 2 minus lambda. And this should be 0. So we have 5 minus lambda into 5 minus lambda 2 minus lambda, and this is 0. Now minus 2 into this 2 into 2 minus lambda. This will be equal to 0. That means we are getting 2 minus lambda is equal to 0. That means lambda is 2. That is one thing. If we take this 2 minus lambda common, then, or else we have this 5 minus lambda square. So 5 minus lambda square minus 2 into 2 is 4. This will be equal to 0. That means 5 minus lambda is equal to 4, and that means this square root is plus minus 2. So if 5 minus lambda is 2 and if 5 minus lambda is minus 2, in that case lambda will be 5 minus 2, that is 3, and here lambda will be 5 plus 2, that is 7. So we are getting 3 values, that is lambda is equal to 2, lambda is equal to 3, and lambda is equal to 7. Now what we want is, we want ground state eigenvector. So we will consider the lowest value possible here and we will find out its eigenvector. So for lambda is equal to 2, we want to find out eigenvector. So that will be 5 2 0 2 5 0, then we have 0 0 2 operated on x1 x2 x3. That should give us 2 into x1, 2 into x2, and 2 into x3. So what we are getting is 5x1 plus 2x2 is equal to 2x1, or 2x1 plus 5x2 is equal to 2x2, and finally 2x3 is equal to 2 into x3. So from here x3 is equal to 1, that's for sure. And from the first equation, from here I can write 5x1 minus 2x2. So that means 3x1 is equal to minus of 2x2. And from here we will get this, if we try to solve these two equations, this can't be solved. That means x1 and x2 both should be 0. So our eigenvector becomes 0 0 1. So 5 1, this is for lambda 1 is equal to 2. This comes out to be 0 0 1, and it is already normalized. So here option C is correct, 0 0 1. Next question. A pair of eigenvalues of the unperturbed Hamiltonian using the first order perturbation theory is. Now according to first order perturbation theory, we have to find out its energy. So first order correction, this is equal to, you have to write the eigenfunction, then the perturbed Hamiltonian, and then again eigenfunction, like this, and we have to solve this. So we'll get it. Now for this first Hamiltonian, we have 3 eigenvalues, and for those 3 eigenvalues we have to find out 3 eigenvectors, and then for each lambda value we will get corresponding energies. We will get the correction and we will add it in original unperturbed energy. Now for the first one we have already calculated. So when lambda 1 is equal to 2, we know phi 1 is equal to 0, 0, 1. Similarly, we have to calculate for others as well. Now left hand side of those equations will remain same that we have already done here. This left hand sides will be same. So this part will be same. Only on the right hand side we have to change. So we have 5x1 plus 2x2, that is equal to 7x1. That means from here we will get 2x2 is equal to 2x1, and second equation was 2x1 plus 5x2. So let me try to solve it for 3 first, and then I will try solve for 7. So 3x2. So this will be here minus of 2x1. Okay. So this will be 5x2 and this is 3x1. So this will be 2x2 is equal to minus of 2x1. So it is satisfying, and finally we will get 2x3 is equal to 3x3. So from here we can see x2 is equal to minus of x1, that is one thing, and x3 has to be 0 because 2x3 is equal to 3x3. So what we are getting is, if I consider x1 to be 1, then x2 will be minus 1 and x3 will be 0. Now this is for lambda 2 is equal to 3, and we have to normalize this as well. So this is 1 square plus 1 square. So we have 1 upon under root 2 outside. Now for the second case, left hand sides will be same. 5x1, then we have plus 2x2. This will be equal to 7x1. So that means 2x2 is equal to 2x1. Second equation is 2x1 plus 5x2 is equal to 7x2. So again 2x1 is equal to 2x2. So they are 1, 1. And 2x3 will be equal to 7x3. That means when we are considering lambda 3 is equal to 7, then we have this is equal to 1, 1, 0. Again we have to normalize this. So divide by 1 by root 2. So these are our eigenvalues and corresponding eigenvectors. Now we will solve for each case. So for first case, E1 dash, this will be equal to this our psi 1 plus this H into this H dash something plus into phi 1. So this is equal to 0, 0, 1. Then we have this matrix which is 1, 1, 0, no 1, 1, 1. Also epsilon is there. So we have epsilon here. Then 1, 1, 1, 1, 1 minus 1, 1 minus 1, 1. Operated on 0, 0, 1. So E1 dash is equal to 0, 0, 1 epsilon, and this will be 1, 1, 1, 1 only. So multiply this 1, then we have minus 1 and then 1. Right. So this will be equal to 0, 0 and then 1. So epsilon only. So E1 dash is epsilon. So that means E1, that energy will be lambda 1 plus this E1 dash. So that is 2 plus epsilon. So we have found one value. Now second one, E2 dash will be psi 2 H dash psi 2. So this 1 by root 2 will be common. So 1 by root 2 into 1 by root 2 is 1 by 2. Epsilon will be there. And then we have 1 minus 1, 0. Then 1, 1, 1, 1, 1 minus 1, 1 minus 1 and 1. Operated on 1 minus 1, 0. So E2 dash will be epsilon by 2 is there. Then 1 minus 1, 0. Now multiply this 1 into minus 1. This is 0. So first will be 0, then 1 into 1 minus 1, this will be 0, 1, 1, 1, 2. Now this will be 0 only. So second energy term E2, this will be, originally it is 3 plus 0, so 3 only. Now for the next term, we have E3 dash, this will be equal to psi 1 h dash, psi 3 h dash, psi 3. That is equal to, now 1 by 2 epsilon, then we have 1, 1, 0, then this matrix, multiply this, so E3 dash will be epsilon by 2, 1, 1, 0, this will be 1 plus 1, 2, then 1 plus 1, 2, then this will be 0. So this is 2 plus 2, and that is equal to 4. So epsilon by 2 into 4, which is equal to 2 epsilon. So we will get E3 is equal to 7 plus 2 epsilon. So here option, we have to check which option is correct. So 7 plus 2 epsilon, so option C is correct. 3 and 7 plus 2 epsilon. So these were all the questions from GATE 2013 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.